Good morning, ladies and gentlemen. May I have your attention, please? Thank you. Firstly, I'd like to know that your quizzes are finished. I finished grading them last night. You're not going to get the hard copies back today. I still need to finish the other B-Day quizzes. However, I will post them on Infinite Campus during the second half of 4A today. So you can log in after 4A and you can see exactly what you got in your quiz. And then you'll get the hard copy back next class period so you can see exactly how you earn partial credit. So once again, I try to get them back to you within 2 class periods. However, the grading god smiled upon me and I was able to get them done just after 1 class period. So they're finished, but I have to enter them in Infinite Campus so you can see them. And then you won't have to wait all the way until next 8A to see your score. Okay, so make sure that you log on to Infinite Campus after 4A. You can check out and see exactly what you earned on the quiz. It'll be out of 50 points in there, right? And so if you see a 42 right in there, don't freak out. That's 42 out of 50, and it says that at the top for the assignment detail. At this time, I'd ask that you raise your hand if you did not get a red mark for today, the 22nd. Is everybody good? Okay, well, a couple of things on your quiz are on today's Bellwork. We had function composition, both with numerical inputs, that is, numbers plugged into my function composition evaluation, or variable inputs, right? A composition of functions where my input ends up being a function. So I made a little bit more space here. On our second slide, we'll be able to see a little bit better. So f of g of 3, it's helpful if I go ahead and rewrite this in nested form. I could write this as f of g of 3. And then it's easy to see that we're going to go ahead and plug g of 3, right? G of 3 is my intermediate value. I'm going to plug that into my outer value f. So where do I need to go first? I need to go and evaluate g of 3 inside. So g of 3 goes to my function g in green. And instead of putting x everywhere in g's row, what am I going to put? Luke? 3. So I'll go ahead and plug in 3, thank you, into g's row and work it out. It looks to me like I get 5 minus 6 is negative 1. So I've gotten negative 1 for g of 3. Raise your hand if you got that intermediate value. Negative 1 for your first step evaluation. Great. Go ahead and tell the class where you're going to put that negative 1 now for your second step eval. Katie? Absolutely. You're going to cube it because you're going to which function rule now? Absolutely. Thank you. So we're going to plug this negative 1 now into my outer function, the f rule, and evaluate it rather in accordance with f's rule. And so here we go. There's f's rule. There's negative 1. We cube it. Remember, that's not times 3. It's multiplied by itself 3 times. And so negative 1 times negative 1 times negative 1 overall is negative 1 plus 8. So I get 7. Raise your hand if you already had 7. Anybody else get 7? Nice job. Thank you. Hands down. I'll go ahead and box that and we'll continue on. So now we've got our setup. I know that g of f of negative 2 would be g of f of negative 2. And so I'll go and I'll work from the inside out in f's rule, which accepts inputs and cubes them before increasing their value by 8. I'm going to go ahead and plug in my inner value, negative 2. So we'll do negative 2 cubed is negative 2 times negative 2 times negative 2 is negative 8 plus 8 is 0. So for my inner evaluation, that is f of negative 2, I'm getting 0. Raise your hand if you had 0 for your inside evaluation. 0. Great. I'm going to go ahead and now put that into my outer function g everywhere except inputs. So I get 5 minus 2 times 0. So I'm getting 5. Raise your hand if you had 5 for number 2. 5. Good job. Thanks, hands down. What questions do you have about our numerical function composition? Put a value in, we'll get a value out, right? That's different than number 3 or number 4. In number 3 or number 4, we're plugging a function in as our input, an entire function with x's into the outer function. So when we work it out and simplify our expression, we'll get x's in our answer. So if we have a function input in our function composition, we'll get a function answer. Let's go ahead and do g of f of x. So g of f of x would look like this in nested format. G of f of x. I know I'm going to go to g's rule, whatever it is, and rewrite it. Except everywhere I see an x in my input g, I'm not going to put x. What am I going to put? Braden?
You're gonna put f is f function.
Absolutely, we'll put f's function into g's input. So f's function is x cubed plus 8. Awesome, thank you. And I'll simplify that if possible. It looks to me like I can distribute this outside factor of 2 in accordance with the distributed property through the parentheses and combine my terms. So my next step would give me 5 minus 2x cubed minus, because negative 2 times positive 8 is negative 16. And then we'll combine like terms. Either order is fine. I'm going to get negative 2x cubed. And I get 5 minus 16 is not 21, right? Make sure you distribute the negative all the way through. This should be 5 minus 16 is negative 11. So my final answer would either be negative 11 minus 2x cubed or negative 2x cubed minus 11. Either one is fine for now. So raise your hand. Does anybody get the negative 2x cubed minus 11? Good job, you guys. That's great work. That's great work. One to go. Go gadget arm. Let's do g of x. So this says go to g's rule. Remember, g accepts inputs. Don't put x. Put g's rule. G of x says go inside of g's function rule and replace inputs with the function g of x. So I'm doing 5 minus 2 times input, and for my input I'm putting g itself, 5 minus 2x. That's pretty sweet. And so I'm doing g's rule into g's function rule where it accepts inputs. Check it out. Now I can simplify that. I'm going to go ahead and distribute that outside factor again, that negative 2 through the parentheses. So my intermediate would be 5 minus 10 plus 4x. And my rewrite would yield 4x minus 5. Raise your hand if you got 4x minus 5. Were you able to do g inside of g? Nice job. What questions do you have about our function composition? Then this time let's consider an inverse function. So if we're given an original, we know that algebraically we can find the inverse of that original function by using our little 4-step process. Rewrite with x and y's, interchange the x and y in the equation, solve for the new y, and then call it g inverse. So let's go ahead and start with g. So g is given by 5 minus 2x. So here's our original. Step 1, rewrite with y equals. So y equals 5 minus 2x. Step 2 is the inverse part. So to get the inverse, go ahead and tell the class what I need to do in my equation. So what I need to do in my equation for that part. Ready? What do I do now to get the inverse, right? What do I do in this equation to start my finding the inverse?
You switch x and y.
Thank you. So I'll go ahead and rewrite, and I interchange the position of x and y in my equation. So this will become x equals 5 minus 2y. And then I'll solve for the new y. Depending upon where that new y is, I'll use a different series of inverse operations. It looks like we'll subtract 5 from both sides. Divide both sides by negative 2. And get y equals, I'm going to get x minus 5 all over negative 2. The final step then is to rename that. We're going to rename that g inverse. And so we'll go ahead and I'll rename this. G inverse of x equals x minus 5 all over negative 2. Now, it's important to note, right, that negative sign in the bottom could be distributed through the top and switch everybody's sign, because it's kind of bad math manners to have that negative sign hiding down in the fraction. You don't have to do that, right? You don't have to do that. You could leave it as is, but it's kind of bad math manners. And so what we can do is take that negative sign and distribute it through the top of the fraction, and we get a new rule. It would be 5 minus x over positive 2. So we've taken this negative sign and we distributed through the numerator, and that changed that from a positive x to a negative x. It changed it from a negative 5 to a positive 5. Now, we could certainly leave it like that, so don't think you have to do this, right? At this stage, you don't have to do that. It'll just make it a little bit nicer. Now let's do our composition. G of G inverse of X. Oh, I can't wait. So let's do G of G inverse of X. So here we go. We're going to go to G's rule, which is 5 minus 2 times parentheses input. And inside of G's input, we're going to put G inverse of X in its entirety. That was 5 minus X all over 2. Take a look. We'll now simplify if this is possible. And if they are in fact inverses, we should get X as the resulting expression. So let's do it. Ready? 5 minus. And now look, 2 over 1, right, times 5 minus X all over 2. This 2 on top divided by this 2 on bottom cancels out. So I get minus 5 minus X. Distributing this negative 1 through the parentheses gives me 5 minus 5, and then minus a negative X is plus a positive X. So lo and behold, we get like terms, 5 minus 5, sum to 0, and we get a positive X out, which is what we wanted. We verified that G and G inverse are indeed inverses because their composition resulted in X. So a negative 2 divided by positive 2 is negative 1. Negative 1 distributed through the parentheses gets us this positive here, negative times a negative. And the resulting simplification yields X, which is what we wanted. What questions do you guys have about today's Bellwork? That was a rip-roaring Bellwork that brings up, right, all that stuff from inverses from 2 days ago. So a lot going on in today's Bellwork, and it's fairly lengthy. But we did get a chance to get your 2 homework assignments passed back to you, and now we're ready to go with today's discussion. Awesome. Let's go ahead and give yourself credit for your linear functions activity. This is based on completion so far. So if you completed all 4, that includes those A, B, C, D. Those A, B, C, D in the back. If you completed all 4, what we're going to do is go ahead and give yourself credit for those. 4 out of 4, 3 out of 4, 2 out of 4, whatever you did, divide, enter, multiply by 4, and then box your infinite campus score around to the nearest half point. Remember, there's no reading questions, so your maximum infinite campus score for assignment number 7 is going to be 4, and it's just that worksheet, that linear functions activity worksheet, 1 page, 2-sided. Now, we're not going to pass it in just yet, okay? All right, we've given yourself credit for completion, but I want to make sure that we have kind of a common foundation on which to build our summary stamps today. 4D, 4D, and 8D on those 2 activities today are going to be similar to the summary. Not the same, but similar. So everybody take a look at your number 4. In number 4, we were asked to summarize our findings by comparing the graphs that you created in 1, 2, and 3. What effect does k have on the graph of y equals kx when compared to y equals x? And so my original graph, y equals x, that was our identity function, right? Our parent function line that went through the origin at a 45-degree angle with slope of 1, up 1, over 1, up 1, over 1 as you move along from left to right, and y-intercept 0. So here's my parent function, y equals x. I better do that in green. Right? There's our parent function in green. Now, let's consider what happens when our values of k, this multiplier right here, were positive. When our values of k were positive, that's your first set of graphs, all of your lines looked like they were in the same direction as this parent function. So when k was positive x, we had a positive slope. We had an increasing graph as we move along from left to right. And so you could say positive slope or increasing behavior as you move along from left to right. If you're a math man or you're a math woman and you hop on the function and you walk along from left to right, you'd be increasing in height. Your y values would be increasing. What about when k was negative? We'll flip it over on the backside. Those are your graphs on the top of your backside. What do all those look like? They all look like decreasing behavior. If you jumped on the left-hand side, right, your marble, and you let go of your marble, they'd roll downhill. So we could say negative slope We could say negative slope, or we could say decreasing behavior as we move along from left to right, like you read. Absolute value of k is greater than 1. That means big values of k, either positive or negative. Large values of k for us, right, meant that we were dealing with a very steep line, either positive or negative. And so, if we had large values of k, absolute value of k is bigger than 1, then we had a steeper line, right, either positively or negatively. We had a steep line. With a large value slope, either positive or negative. But if my absolute value of k was in between 0 and 1, a fraction like 1/2, right, or 2/3, then I had a more gradual line, right? I had a less steep line and a more gradual line. I'll call that more gradual slope. So now we've got our effect of k detailed and summarized for linear functions, right? When we did parent function y equals x, the identity function. Today what we're going to do is investigate that effect of k, that multiplier, on different parent functions. We'll be looking at the squaring function, we'll be looking at the reciprocal function, and we'll be looking at the inverse squaring function today, okay? We're going to do a little bit of directions modification in just a moment, but first I want to make sure you get credit for your assignment. So at this time, let's make sure our name is on the front page of our linear functions activity worksheet. You're going to go ahead and pass them back to front. Your Infinite Canvas grocery box nice and big on top, and I can get you credit for these in Infinite Campus during today's class period. So again, pass them back to the front. Please keep them in the same column. I appreciate your help. I'm going to take them, put them up a little on the front, that first pile on the long time. Thank you, guys. Thank you. Thank you. Thank you very much. Very good with number 7 if you did it. Number 7. Awesome. So let's go ahead and set up today's activity. So we looked at the effect that k had, the multiplier, in front of my parent function, the f of x equals x. And we noticed that depending upon the value of k, either positive or negative, our graph had a different orientation, a different direction. We're going to examine that effect now on other functions. So what we're going to do today is we're going to look at the effect of a multiplier k on the squaring function, the quadratic function. Recall that this is not in a note sheet right now, it's from your green sheet last time, but recall that for our squaring quadratic function, f of x equals x squared, just look, and our input values were squared before pairing them with an output y value. So negative 2 squared is 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. A quick sketch yielded what we called a parabola, right, or bowl shape, right? It was a U shape here, a U shape. Today we're going to examine what happens when we take a multiplier of some constant k value and we put it in front of that parent function x squared. We're going to see what happens to this graph. Did the shape of the arms change? Did the position, right, of the arms change? Did the orientation of the graph change? And so we're not filling everything in here. I just want to remind you that the squaring function is called a parabola. And for 4a in your squaring functions activity, we're going to say what orientation does the graph in question have? And so for part A and part B, we're thinking what orientation, what direction is the U, facing? The second function we're going to investigate today is the reciprocal function. And so you don't have to recreate this graph, but I want everybody to find their green sheet. Everybody find your green sheet. Recall the reciprocal function equation was given by f of x equals 1 over x. It took key inputs and took their reciprocal. If we continue to choose x values and pair them with output y values, we get what I affectionately call hoops on the graph. So what we're going to do now is go ahead and suppose that we took some multiplier, some k value, and multiplied it to that function. We're going to see what happens. In order to get your 4a, b stamp there, I want to know in which quadrants these branches on my hyperbola lie. So a parabola is a y equals x squared equation. A hyperbola is a y equals k over x equation. For your 4a and 4b stamps in activity 2, the reciprocal function inverse squaring, I want to know where your branches lie. So that we're all using common notation, we'll go ahead and label this quadrant 1, quadrant 2 with Roman numerals, quadrant 3 with Roman numerals, and remember a 4 with Roman numerals is like the IV. Right? And so it starts here with positive x, positive y quadrant, and then we go around the wheel. We go around the wheel, 1, 2, 3, 4. I want to know which quadrants for 4D, or for 4A rather, and 8A in order to get your stamps. That's where you're going to be seeing where your hyperbola branches are. And lastly, your inverse squaring function. Your inverse squaring function was 1 over x squared. And that created key points -2, 1/4, -1, 1, -1/2, 4, 1/2, 4, 1, 1, 2, 1/4, 3, 1/9, etc. This was the Atari symbol, right, where we had our inverse squaring branches. I again want to know in which quadrants these branches lie for the inverse squaring function based on our multiplier k and what that does to the graph in order to get your stamps. Today, you'll have an opportunity to work in your small cooperative learning groups, and you're going to earn stamps, right, based on going through the activity in order together. You may use the graphing calculator to generate points in the table or check your graphs if you so choose. However, in order to get your matching stamps, you have to complete those non-calculator. So your matching stamps must be completed non-calculator. You're now going to summarize your findings, right, after 4D, and then complete the matching to compare those graphs without a calculator. After you have reached a stamped eligible item with your group, you're going to raise your hand, and I'm going to come to you. I'm going to come to you, and I'm going to get you stamped all at the same time. After you've gotten your matching stamp, right, you must wait till you get your matching stamp. Then and only then can you go on to your reciprocal and inverse squaring functions activity. Again, 4D and 8D, we're looking for the quadrants, bless you, in which quadrants do the branches lie. And then the matching must be done non-calculator in order to get your stamp for that. Everybody, your quadrants again go 1, 2, 3, 4 around the wheel. Thank you for using Roman numerals, capital Roman numerals, okay? And then we're going to come together. We need about 10 minutes for our closure today. And so we're going to come together at 9:35, which gives you plenty of time to complete these. We're going to go in our small groups, and we'll come together for closure. I'm going to pause the recording, and then we'll rejoin when we come together for closure. Thank you, ladies and gentlemen, for returning the desks to the regular position. I appreciate that. You guys did a great job working together in your small groups. So, if you still need stamps, you can complete this as part of your regular assignment and still get full credit so long as you have it done by Bellwork next class. So I know several of you were very close to your last stamps. You can still get full credit, just complete next time for Bellwork. At this time, however, we need to take a look at your closure for day 8. So everybody find on your notes your closure for day 8. We can now generalize the findings of that multiplying factor, that a constant multiplier in front of your parent function. And so you guys looked at y equals x squared graphs, your total bowl-shaped graphs. You looked at your y equals 1 over x, your hyperbolas that appeared in diagonal quadrants. Your branches were in 1 and 3 for the parent function. You looked at the inverse squaring function, right? Those were the branches that were up with reflectional symmetry, or for negative k values, down, right? Where your branches were mirror images of one another when reflected about the y-axis. So we're going to go ahead and summarize our findings and see if we can come up with descriptors for positive a versus negative a constant that would apply to all 3 of those parent functions, not just our line or our parabola. How could we state it so that it worked for all 3 of your parent functions that you investigated today? Well, a, when we had a parabola being positive, was the same orientation, right side up bowl shape. In fact, that holds true for all of your parent graphs. Positive a values made your hyperbolas and your diagonal quadrants 1 and 3 for all of them. That's the same as your parent function. And positive k values made your inverse squaring branches up. That was the same as your parent function. So for positive a, we can summarize that as applies to all of our family of functions by saying same orientation as your parent function. The right side up parabola if it's a parabola. It's quadrants 1 and 3 if it's a hyperbola. Quadrants 1 and 2 if it's an inverse squaring function. So same orientation as your parent function. Versus a negative opposite orientation or a reflection across the x-axis. Up went to down. Right side up bowl shape went to upside down bowl shape. Or hyperbola, quadrants 1 and 3, flipped to quadrants 2 and 4. So opposite orientation. We'll say reflection about x-axis. For large values of a, what did that do, Margot?
That made it taller y for the same height.
Absolutely. That made taller y coordinates for the same x coordinates. Taller y coordinates, taller arms, taller branches. So we'll go ahead and summarize that as taller y coordinates for a given x value. Versus small values of a, either positive and negative, but in between 0 and 1, made shorter y coordinates. They were scrunched down closer to the x-axis. So we'll just summarize that as shorter y coordinates. Take a minute and make sure you have an appropriate response for your closure on day 8. And please note, your assignment number 8, again, is not from a book. It's that packet that says Day 8, assignment number 8, it's that packet where you've got lots of different matching in the graphs to practice with your parent function. If you'd like to use your green sheet to help you complete your Day 8 assignment, please do so. I want you to use your green sheet these first couple of days. Go ahead and pack up. You guys did wonderfully, and I'll pause the recording.